our topic of today is creating Azure Open API application. I really excited about having Mike in Washington here. I just have to confess to him, I have been following his work for a long time. His Blazor help website is a blessing. Everyone come here and take a look. I remember, and Jose can attest to that, Michael, we did a B2C application that we have to actually connect all the parts, and your post and your video and your, like, I followed it to the letter. So that was really a blessing for me. But also not only that, a lot of other great things about Power BI with Blazor. So if you have not seen, if you are a Blazor developer and you have not seen the Blazor help website, please go for it. And we had here, Michael, a couple of months back, Jeffrey Palermo here in the meetup, and he has a really great podcast about Azure DevOps. But what I really like is every time he starts any episode, he asks the guest, hey, how have you come here? How did you start with C#? How did you start with your development career? What have been your highlights that have taken to this point? So if you want to introduce yourself a little bit to the thing, and then we can actually start going through the topic of today, that would be great.
Okay, for me?
Yeah, please.
Yeah. Okay, hi. Let me go ahead and, am I sharing my screen yet?
Yes, please, go for it.
Sorry, go ahead. Okay, 1 second, screen, share, there we go. Okay, hi, so I'm Michael Washington, and I'm a Microsoft, well, let's go here. Oops, hold on. Oops. There it goes. Okay. Yep, I'm a Microsoft MVP, and basically all-around geek. I got started with Blazor way back when it first got started, but before that, I was doing Silverlight, and before that, you know, even classic ASP. So yeah, I go way back. Currently, my focus is mostly on the AI stuff, and that's why I wrote this book. And I've written a number of books on Blazor, but this one over here on the left side, let me see if my annotation thing is working. Yeah, this book right here. So this is the one I just published last month. And I basically wrote the book because I wanted to learn about AI. And just so you know, this presentation is about Azure OpenAI versus OpenAI. So what Azure OpenAI is it's where the OpenAI models are being served through the Azure portal. So instead of paying OpenAI for the services, you're paying Microsoft, but it's the same stuff. So I know that OpenAI just had a developer conference 2 days ago. They announced a bunch of new features. Those features will come to Azure, but it usually takes about a month. So I'll just, you know, cover that there. So basically this is the agenda. I think it takes about an hour. Basically I'll take questions throughout, so just yell out the question, and there you go. So the first thing I was going to start off with was to show you a project that I'm working on right now. It's an open source GitHub project, and the reason why I wanted to look at it to start off is it's an example of how you could use AI to do something useful, and maybe it's something that's kind of you know, something you guys may not have seen before. So this is a project that I plan to spend the rest of the next year working on. Then we're going to cover, you know, what is Azure OpenAI and why would you want to use it? So if you're a total beginner, you don't know anything about this stuff, don't worry, we're going to start from scratch. The next thing we're going to do is we're going to create a Blazor chat application using Azure OpenAI. And I'm going to go through every single line of code. And the reason why I can do that is it's really not a lot of code. We're going to cover things like fine tuning, so that you may have heard about, you know, fine tuning a model and that sort of thing. But then the last half, the last three things, we're going to talk about embeddings and vectors. Now, most of you may not even know what that means, and that's fine. And that's why I title that Embeddings and Vectors and Why Should You Care? We're then going to cover Azure OpenAI has a service called Bring Your Own Data. and it allows you to have your own private data, yet put a chat application on top of it. For example, you can have like a bunch of PDFs, and people can chat with the PDF and ask questions of it. So it can like replace your, your help desk and that sort of thing. So I'll totally cover how you use that service because it's a low code sort of thing. And then finally, we're going to build our own application that does the same thing. And the reason why, you'd want to do it this way is it's literally 100 times cheaper. So it's the most inexpensive way to create your own full AI application where you can chat with your own private data. So that's what, how we're going to wrap it up. So let's first actually start off with, there we go. So hopefully you'll be able to see this video. So what this is this is an application that I'm currently working on, which allows a person to click a button to say, I want to create a story. They give it a title and they give it a synopsis, and they can indicate how many chapters they want the AI to write. So they click this button and it, calls the AI, and it then writes the chapters. So you have the details, and it's a story about the three little pigs, and it broke it down by timelines. So there's the building the house and the wolf blowing the house down. It then has the various locations. So there's the brick house, the mother's home where the pigs, started. There's the stick house, and then there's the characters. There's the three little pigs. There's Charlie, Joe. There's things about them. So Charlie, he's the one who builds the house out of bricks. Joe, if we go to history, he's the one who builds his house out of sticks. And of course, the wolf, his history is that he tries to eat the pigs but fails. And then when we go to chapters, we see that there's 3 chapters. Each has a synopsis, and we even wrote the first paragraph of each chapter. So all this was done, through the, making calls to the AI based upon that synopsis that was put in there. I, of course, have the logs, and the logs are kind of showing this is the communication between this actually is a Maui app, but it shows the communication between the Maui app and the AI. So I just want to show you one more thing really quick here, again, to look at the synopsis. So everything you saw was based upon just this synopsis that was, just that was sent to the AI. But when I sent it to the AI, I said things like, hey, break down the chapters, break out the characters, break out the locations, and that sort of thing. And then I used the app to kind of coordinate things, so that the way this is supposed to be used is that a person is supposed to be able to, go ahead and add, more locations, add things about the characters, and then be able to say to the AI, hey, why don't you complete writing this chapter or rewrite this chapter, yet stay on, know that, well, wait, Charlie is the pig that had the stick house, and, and don't get confused. So this is a project that I'm working on. I'm pretty excited about it. And it, of course, is using the techniques that I'll be covering in the presentation today. So, and like I said, if you have any questions, go ahead and just call them out.
Yeah, we have a question, Michael.
Sure.
So David is asking that, will you go the other way where you paste the whole story and it gives you the chapter, it summarize the chapters?
Yeah, that is actually one of the things I am planning to do when I flesh this thing out. So right now, I'm just trying to get the basic thing here, but yeah, I'll have it so that you can go the other direction. And the AI, of course, it can handle that, no problem, So okay, so let's go into what is Azure OpenAI and why would you want to use it? So to use Azure OpenAI versus, again, OpenAI. So for OpenAI, you just go to OpenAI, their website, you sign up, no problem. With Azure, you have to, of course, have an Azure account, and you have to click on a button to request access. Before, this was kind of hard to do, but now they made it a lot easier. So but you do have to still request access, and then they have to approve it. So once they approve it, you'll be able to go to create resource, You'll search for Azure OpenAI, you'll click create, and boom, it's created. So it's that easy. If you go to the Explore button, it'll take you to it'll go to like a new website, which is the Azure OpenAI Studio, and it looks like this. The first step is you have to deploy a model. So if you go to the deployment section and you click create new deployment, you'll be able to select a model. So right now, GPT 3.5 Turbo, 3.5 Turbo is one of the most cost-effective models. You're charged by how much traffic that goes to the model. So this is the fastest performing and really one of the cheapest models. There, of course, is GPT-4, and that's the one that most of you are probably already familiar with. And so I usually use both, but I try to use GPT 3.5 whenever possible. However, 2 days ago, OpenAI just announced that the GPT-4 is like they cut the price in half. So again, it's going to take about a month for that to roll into Azure OpenAI. So when it does, I'll probably be using the GPT-4 Turbo because there's now a GPT-4 Turbo, and I'll probably be using that. But when I made these slides, GPT 3.5 was the one to recommend. Okay, so you select a model, and then you select a deployment name. You can make your deployment name different than the model name, but I always usually make it the same. And then you have a model deployed, and now you can do something with it. So the first thing is like completions. So if you go to the completion section, you see number one there, I select the model, and then you can select some example. In this case, I selected chatbot, and that's why it creates this here. However, I could just type whatever I want. What is showing you here is that it's telling the model, hey, this is a conversation. The human said, hello. You, the AI, said, I'm here to help you. The human said, I'd like to cancel my subscription. And then right now here, it's asking the AI to complete this. So when you click generate, it basically puts there in green. It says, of course, please provide me with your account information. So when we talk about the AI in this case, we're talking about LLMs, which stands for large language models. And the point of it is that it understands language. So this response in green, it makes sense based upon, what came before it. And that really is what they do. They're not really good at math. So if you said, what's 2 plus 2? It'll say 4. But if you said, what's 2 plus 2 minus 7 plus 3, times 8, it most likely would not give a good answer. And that's because language is what it's good at processing. Math, not so much. So what is a prompt? A prompt is what you send to the large language model, and a response is what you get back. The prompt is kind of like where you do the programming. What is the anatomy of a prompt? In my experience, it comes down to these 3 things. Number 1, you tell the AI what you want. Number 2, and this is very important, a lot of people forget this, explain what you don't want. And then 3, when possible, provide examples. There's also a lot of settings. And again, these settings can also be done programmatically. I'll quickly cover what these things do. You have temperature, which controls how creative the model is. Usually in my programs, I have the temperature set to 0 because I don't want it to be creative. But there's a lot of times when you do want it to be creative. The max length in tokens. Again, is just telling the AI, hey, you can make a long response or a short response. You have stop sequences where you can have special words where it'll stop responding. You have top probabilities. Now this one is kind of interesting because it kind of goes with the temperature. But what happens is that the large language model, when it's trying to give a response, it basically has this vast amount of information inside it. And it doesn't want to, for example, if you have a higher temperature, it doesn't want to say the same thing over and over again. But as it's starting to respond, it may start, for example, to repeat certain things. So between top probabilities, frequency penalty says, hey, if you're repeating certain things, if you're repeating, stop repeating, be original. And then you have presence penalty, and that says, how often it should not try to change the subject or not change the subject. And then you have pre-response text and post-response text. So there's some settings that you can do. However, mostly with my programs, when I'm calling it programmatically, I pretty much have default settings. Any questions on this one? Okay, I'll go ahead and continue. All right. So that was just basically you send something to the AI and something comes back. But now you have another mode called chat. And this is the one that you all are really familiar with. So in the Azure Studio, if we go to chat, the screen kind of looks like this. And the difference is that with chat, it remembers context. So if I said, my name is Michael, it responds, sure, how can I help you? And then if I say, what's my name? It remembers that my name is Michael. Whereas with completion, if I tried to do this, I would say, remember my name is Michael. It would say, sure, Michael, how can I help you? And then I would say, what's my name? And it says, I don't know what your name is. So chat is just, it remembers the previous conversation. However, there's a limit. So if we go to settings, we see that there's a setting that you can change, how much past messages can be remembered. And it's based on tokens. And a token is kind of like a syllable in a word. It's not quite, but if you kind of want to know what a token is, think about syllables in words. So the models only have, what they call a token window. It's only so big. However, again, OpenAI just announced that the GPT-4, its token window will be about 32,000 tokens, which is about 600 pages of typewritten text. So they're quite big now, and that's probably not going to be that much of an issue. But in the beginning, they had like token windows of like just 4,000 characters. So there's that. And again, they still have the parameters that I covered before. All right. You can also create an application. So if you click the view code or the deploy to, it will take you for deploy to. You can just fill out some information for web page, and you click deploy, and they'll automatically create a web, page for you. Or if you click the sample code section, they'll show you how. Okay, here's how you can, for example, select C#, and you can programmatically call the API. So let me show you a quick demo here. Oh, sorry. This is the one where I show the actual website. Give me a second. There we go. All right. So we're going to go into my Azure website here. Do that. And make this a little bit bigger. Okay. And let's go to my East service. Okay. Oh, yeah, East. Where's East? Sorry, pardon me here. I think that's East. Microsoft, we want to give feedback. Not right now. I'm doing a presentation. Okay. Oops. That's not what I wanted. Sorry, I zoomed in so you guys can see, but unfortunately, I can't see my controls. Okay, let's try this one more time again here. And okay. Give me a second here. And there it goes right there. So this is what the studio looks like. Like I said, notice they opened up a new window. There we go. Maybe later. Okay. So this is kind of what I was showing you here. So I first talked about completions here. And of course, I went into the one that doesn't have a model deployed. And okay, let me try one last time here to get the right one. It's got to be this one. And studio. And that. Okay, it actually does have a deployment. Okay. So here, if I type, oh my God, people. Done. So I can say, how can I use Azure? And so just like I said, simple stuff here. If I wanted to view code, this right here is showing me how, if I did C#, these are the libraries I need to install, and here's some sample code that would work. And, you know, I could just run this and I can, you know, communicate with through the API. And if I wanted to deploy a web app, I can, you know, use this function here. So just wanted to show you what it kind of looks like. And current slide. All right, so let's call the API and let's create an app. So we're going to create this app here. So it's a simple chat app, which is kind of just basically doing the same thing I was kind of showing you before, but this time, you know, using our own C# code. So we'll be able to put in a prompt, you know, write a 10-word description of Azure OpenAI. We click call ChatGPT, and it would then give us a response. And of course, we can continue going back and forth, and it would, you know, have context, so I wouldn't have to repeat myself. Each prompt I gave it, it would know, you know, what came before. So I would, you know, like I said, I wouldn't have to keep repeating myself. Okay, so let's create the application. So we go into Visual Studio 2022, and we select Blazor Server App, and we're going to call it Azure OpenAI Chat. And we're going to install the NuGet package. And the package we're going to install is the Azure OpenAI that's created by Microsoft. It's still marked as pre-release as of now. It works fine, but when you say, why is it pre-release? It's still pre-release. And we're also, so that we can get the formatting, we're going to use another NuGet package that you're probably already familiar with called MarkDig. And what it does is we're going to ask the model to give us its responses using Markdown. And MarkDig will display Markdown in our Blazor app so that things are nicely formatted. So we're going to go into app settings, and we're going to put these settings in. So what happens is that if we look inside the Azure OpenAI Studio, and remember I told you we had deployments, I deployed the model called GPT 3.5 Turbo. So in my app settings, under deployment name, under Azure OpenAI service options, under deployment name, I put the model there. As far as the keys, when I go to my keys and endpoints, I click the button to show my key. I put the key here, and the last thing I need is the endpoint, and I put the endpoint here. So basically, you need 3 settings in order to communicate with the API. So then, now of course, I recommend that you actually use manage user secrets, and you put these settings in user secrets rather than your app settings.json. But the point is you just need these 3 settings. So now I'm going to so this is the application that we're going to build, where, you know, I could put in, and you see the reason why I'm using Markdown is you see how the 1, 2, 3, 4, 5 is all nicely formatted. That's because, and I'll show you where we ask the AI to give us the responses back in Markdown. Okay, so now we're going to create the UI page. So, however, we're going to go to string extensions and create a file called string extensions. And this is where we're going to create a extension called to.html. So what happens is that we'll pass to this extension a string, and it will call that mark dig to return nicely formatted Markdown. Then we're going to go to the host CS.html page, and we're going to add this piece of JavaScript, which what happens is that it causes the window to scroll to the bottom. So as things are put into the chat window, it'll constantly scroll to the bottom. So we're going to end up calling this scroll to bottom JavaScript method. So for the index page, we're going to go to index.razor, and we're going to put our using statements. And this CSS is only so that the chat windows, you know, we have something on the left and something on the right. That's just CSS to control those chat bubbles. That's all this is. And here is displays the chat. So if it's a user, you see we're floating to the right. And if it's the AI talking, you see we're floating to the left. So this just displays the chat bubbles, but they're formatted with the CSS that I showed before. This right here is the button to call ChatGPT. So it's going to call a method called call ChatGPT, which I'll show next. And then, of course, we have the restart button. And when it's processing or thinking, it'll show the processing. And if there's an error, it'll show the error message. So, this guy right here. So this is the index page here. And what I do is I first put that, the using statements, and then I put in the CSS that will format the chat bubbles. And this right here will display the chat messages. So it's in a for each loop there. And then I have the code for the button at the bottom. Also, there's a place for them to, of course, type in their message. And go here and cursor. Okay, so now let's look at the code. So this is the code section. I, of course, just have some fields to store the chat messages and the prompt and that sort of thing. This runs, this is the initialize, so this runs when the page loads. So the first thing I do is I get those configuration settings. So remember those 3 settings. There was that endpoint, the model name, and of course the key. And then I have this initial system message where I'm telling the AI, you're a helpful assistant. And this is also right where I say, you always reply in Markdown formatted response. And I add this to the collection of chat messages. Also, so that the screen will always keep scrolling to the bottom, the on after render, which triggers every time you do a refresh, it's going to call that scroll to the bottom that I showed you before, so that it scrolls to the bottom of the chat window automatically. And this right here is if they click the restart button, it just resets and clears the chat messages. Now here, this is what happens when they actually type in a chat message and click the call ChatGPT button. First, I set processing to true, so that I call state has changed, which will cause that to scroll to the bottom of the window. I then have our new OpenAI client. So this is calling the NuGet package, passing in that endpoint and the key. So client is what we're going to use to then communicate. So I then, so I have this collection of chat messages. So I add a chat message from the user. So that's why the role is the user. And this is the prompt. So this is whatever the person had typed in, in the box. Then remember I showed you all those settings. This is where you can have most of your settings. Notice how I told you I have the temperature really low. So I have it 0.7. So it's about as low as you can go. Some of the other ones, I just, like frequency penalty and presence penalty, I just set them to 0. And
So,
then,
Michael, so that
yes.
means that it will not repeat itself and it will not talk about any new topic. Is that?
Yeah. It will stay on. What I wanted to do is I wanted to concentrate on the prompt. Okay. Whereas if I had these higher, you could say something like, please tell me how to create an account in Azure, and it may start talking about, going to the park. You know what I'm saying?
Yeah,
So
and also they repeat itself a lot. So they give you the prompt and then they say in conclusion and they repeat the same thing, or they just, I don't know, like.
well, in this case, because I'm not giving a penalty, it could get very repetitive. So the penalty, you're saying you're penalizing it for repeating itself. Sometimes you may want that. The presence difference says the word choice will be different. So the presence of certain words like the word Azure, if you penalized it for using the word Azure too much, it would then say, okay, I'm not going to use Azure. I'm going to use cloud service, or I'm going to try to use some sort of, you know what I'm saying? But for the most part, like I said, I put these at 0. However, you know, it really depends on the situation. So you might decide that, no, I don't like it at 0. I want to raise it up higher.
Got it.
So it's just me. I'm not saying it's the right way, So this is continuing the code. So this is where up here is where we actually make the call and we get the response back from the AI. So it comes back as a result. And what happens is that I look for the very first thing, because there could be multiple things in there, but usually, well, 99% of the time I just get the first thing, and I add that to the chat messages, and that causes it to boom appear on the screen. So that's it. I also kind of count the tokens, and I kind of keep track of the tokens. If there's an error, I'll handle the error, and then I clear out the prompt box, and then I set the processing false so that the spinner stops showing. But that's it. That's it. So, and I literally showed you every single line of code. So
Nice.
as you can see, it's not that hard. Any questions? So let's take
I
a
think
quick
that is
look.
pretty straightforward.
Right. Yeah. It's just not hard. It's simple API calls. So this right here is just showing you, again, putting that last code in there. These are the variables and the fields. And then we'll have the uninitialized method where I'll grab all the settings from,
We have a question, Michael, about
sure.
how can we like this is like a add-on to the application, but how can we like enable attachment to that chat so we can put like a picture or something and ask? Is that possible there?
The model that they just announced, 2 days ago, does allow for attachments. Again, it won't make it to Azure for about a month. So just 2 days ago was when they came out with that. So So yeah, it's so you can do it now, but like I said, it's only as of 2 days ago.
Yeah. And another quick question. Let's say that we do something like this. Like we have a lot of clients of a lot of friends that are working on line of business application. What
Right.
about the security of your data? Everything that is put in the chat.
That is why you'd want to use, there's two big reasons for using Azure. Number one, it's faster because the deployment that you create is your own deployment. It's a copy of the actual OpenAI model, but it's your instance of it, and you can crank up the resources. Whereas like right now, OpenAI is having some big performance issues, so everyone's suffering. So if you use Azure, you're isolated. And also Microsoft guarantees that even they won't look at your data. So that's a reason for, if you're a business, I would recommend using Azure OpenAI. The cost is the same as OpenAI, but it's better performance and you're totally isolated. So hopefully that answers the question.
Yeah, absolutely.
Okay.
Yeah, it can go with like governance. I think that is the term that they use,
Yeah.
like governance of your
Yes.
data.
Yes. Right.
So, Michael, we have another question.
Sure.
What about if we're dealing with domain language, meaning like if you are in a medical field that you need
Oh, well, that's where, okay, now, okay, okay, boom. This is fine tuning. Okay.
nice.
So questions like that, I wanted to have a slide on fine tuning. So most models, their information got cut off a year ago. Again, 2 days ago, OpenAI announced that the newest models, the cutoff is June of this year. So, however, the question was, what if I have something that's a special domain? Okay. So for example, my company, we make medical instruments. It's not, the AI models are not trained on it because this is our private behind our firewall, our whatever. But I want that information in the AI. Can I use fine tuning? While fine tuning can be used to add information to the model, I do not recommend it. The reason why, one, it usually won't do what you hope it to do, meaning, even though you put that information in the model, when you start talking to the model, it won't actually spit out the information the way you want it to. So it's in there. So it's like the person knows about this information, but when you ask it questions, hey, what scalpel should I use? What number 7 scalpel should I use? It goes, oh, I don't know. Maybe you should just use, this other scalpel. And you're like, no, I trained you. I spent, and by the way, fine tuning costs a lot of money and takes it takes a considerable amount of time. You're like, we trained you on this information. You know about scalpel number 7B. Why won't you, why won't you,
Yeah.
bring it up when I ask you this question? Because it's hard. It's like this big, vast, storage of information. Getting it to give you what you want, where you want, fine tuning is not the way. However, what I am going to show you for the rest of this presentation, I will show you how to get it to do what you want it to do, the way you want it to do it. So fine tuning is possible, but I do not recommend it because it really doesn't give you what you want when you want it. Your answer is embeddings and vectors. So now we're going to dive into this. Any questions, please, ask questions as I go through this, but this is the answer. Okay. And this, of course, is what my book is about. First, let's back up a little bit. What is a large language model? The point is that it's really this right here. It basically predicts the next word. That's what it does. It just predicts the next word. It completes things. You give it a bunch of stuff that's in a language, and it then gives you a response, which in essence is just completing. So if I say, write a short poem about flowers, and it writes a poem about flowers, all it was doing was completing what I previously said, you know. However, if I said, John went to the, and I stop, it's going to come back with store. That's not answering a question. It's just completing the sentence. So it's important to note that that is all it does. Again, like I said, it doesn't handle math very well. It just completes language. Okay. So that's what this slide's to do. With that said, how do we do what we're trying to do, which is my company has private data. I want you to complete my request. So if I say, let's say my company is uh we like I said, we have medical supplies. If someone says, please tell me what what model number is a 7-inch scalpel, I want you to complete that request by saying, hey, model number 257 is a 7-inch scalpel. That's what I want you to do. How do we do that? We use a thing called the RAG pattern, retrieval augmented generation. What happens is that we first put our information into a database, and specifically a vector database. And I'll explain why it specifically needs to be a vector database. But we first programmatically search our vector database for relevant information. So for example, I've put into the database every single product that my company has, all the different scalpels and all the different, cloths and whatever. I put that into a database. When a person asks a question, what scalpels, what model numbers of scalpels that are 7-inch scalpels, we first search that database and we pull up the information about 7-inch scalpels. We then pass that information to the AI, and then the AI gives us the answer that we're looking for in the way we're looking for it, and it does it reliably every time. Okay, so this 3 steps is how it's done. This, by the way, is how Bing API works. Bing search works. This is the pattern that things do. So when you go to Bing, you say, "Hey, what's a good place to what's a good hotel in Pasadena?" What it does is that it, of course, has all this information in its, database, but it then finds a bunch of relevant links. It then pushes that information to the AI, and then the AI then gives you the response. So this is the pattern. Why do you need to use a vector database versus just a normal database? The reason why is that you need to have chunks of information, and they need to be granular. So a vector database is the best way of storing information and retrieving it in a granular fashion. And I'm going to show you some examples to show you exactly what that means. But if you use, like, say, a normal SQL Server, keyword search sort of thing, while you can get pretty, decent results, a vector database allows you to get the best, granular results that's related to the query that a person asked for. And again, I'm going to show you some ways of doing that. However, your first question is, okay, I need these vectors, but how do I get these vectors? And the way you get the vectors is you do a process called getting embeddings. And the way you get an embedding is you actually call a model, a different one, not your normal GPT Turbo that I was showing you, but it's a different model that you call that produces embeddings. And an embedding is basically a mathematical representation of a word or phrase. So if I passed it the word embeddings, I would get a series of numbers. If I passed it, get your embeddings, I would get a different series of numbers. However, the series of numbers for embeddings and the series of numbers for get your embeddings are mathematically similar. And that is how it does its searching. But again, I'm going to show you a visual of this. So if you're getting lost, you're like, what? So this is the application that we're going to build. Well, as an example. So if I typed in, how can I play audio in a Blazor application? This is kind of showing you my vector database. The words, how can I play audio in a Blazor application? The word Blazor is turned into vectors or embeddings, actually, which consist of vectors. The play is done same thing, and audio. Inside the database, I already have the word application, playing, and MP3. Now notice the word audio and MP3, these are two different words, but they are related because the models, when they were trained, they know that audio is near MP3. So this is what comes in, and this is what comes out. And the reason why that comes out is these relations are made. This application, playing, MP3 is pushed to the model, and then the model taking the query plus this, this other information, that's how it's able to come up with this response. Any questions? Now, so now we're going to finish off where I'm going to show you two ways to implement this pattern. One is Microsoft has a built-in service, and I'm just going to go through and show you how their service works. And then to close out this presentation, I'm going to show you how to code the whole thing yourself manually. So Microsoft has a service where you go back into Azure OpenAI Studio and you click this bring your own data. It follows the same pattern. The user enters a prompt, a search is performed, which, through a vector database. The information going back to the LLM is called grounding. So it's passed to the model, and then you get a response. This is kind of what their solution looks like. This right here, this is their solution. It, of course, is talking to the OpenAI models. But what it does is that this is its vector database right here. It stores it in Azure Cognitive Search. This works great, but this is not cheap. And your private data, you just put it into just an Azure storage. They'll automatically create a web app for you, but of course you can make your own web app if you want. And this happy face person here is you. So to use it, you go into Azure OpenAI Studio, and you just go ahead and click the bring your own data to get started. However, all it does is it basically says, oh, you need to set up a storage, and you need to do all this stuff. So I'm going to show you, this is the steps. So you first go to Azure Cognitive Search, and you create a new search service, and you just create it. And this is the problem. The thing is not cheap. So it's $75 minimum. However, they want you to have 3 instances so that you'd be at about $160 minimum per month. And just go ahead and pay the money. And when you go into the resource, now, if you want to have semantic search, which before they had the vector search was the only thing available, that was $499 a month on top of the other cost. However, they now have a vector search so that you actually can now get away with just paying the $75. Now you need to get your sample data in there. So in this case, I went to the Azure, Microsoft Azure documentation, and I downloaded everything as a PDF. So this was, I think, like 100 pages. So I downloaded the PDF, and then I created an Azure storage account, and I then created a container called OpenAI files, and I then selected it, and I then uploaded that PDF. So all I did was upload a PDF into the container. Once you have that, you can now go back into Azure OpenAI Studio, and you click this Add Your Data button, and then you click Add Data Source. And the reason why I had you set up all that stuff is because it says, select a data source, Azure Blob Storage. This is where I uploaded that PDF. And yeah, this is where I uploaded to this OpenAI container. Then you have to have an Azure Cognitive Search. So I already had that. And then they're saying, now you need an index name, because what it's going to do is it's going to take whatever's in the storage, it's going to run it through the cognitive search, and it's then going to create an index in the cognitive search. And this is what the app is going to use to, search for grounding data. So you just click Save and Close. It then ingests the data. It says, I'm done. If we go back and look inside our Azure Cognitive Search and we look at indexes, we see that an index has been created, and we see that it's created 17 documents. This is what's called chunking. So instead of just ingesting the entire PDF as one big file, it breaks it up into 17 smaller chunks. And you say, why does it do that? Well, I'll show you in a moment why it does it that way. So the nice thing is that, boom, your app is done, and it's totally usable at this point. Notice I didn't have to write any code. If I go in and I type in, what is Azure OpenAI Service? Now remember, it's inside that huge PDF document because I downloaded all the documentation from Microsoft on Azure OpenAI. When I click the button, this is the response I get. This information here came directly from the PDF. However, these sentences were not necessarily in the PDF, meaning the AI is smart enough to, give a response where, the language makes sense, and the sentences make sense, and it flows well. This references here, this is why I did chunks, because what happens is that it said that this response here was contained in this chunk. So remember, there's a whole PDF, but it's just this chunk is what it used for this particular response. And so this is basically, like I said, how it works. If you want to make a true web app, because this right here is inside the studio, you just click the Deploy To button, add a new web app, fill in some information on, your resource group and your location. You hit deploy. It thinks about it and creates a web app. And we click this button to say launch web app. What happens is initially they make it so that you have to sign into it, but you can, take that off if you want. And then you have, a web app. So let me just show you what that looks like. Yeah, here it is. So here I go into the studio here. I've already set up all the other stuff, so therefore I can just say add your data, add data source. I fill in the various information. I say I want the index name to be open-AI-new. Click the button, click next. It thinks about it. Well, no, click save and close. It's ingesting. It's basically looking into the container where it'll find the PDF, but it could have been multiple PDFs if I wanted, and it then chunks it. So now I can just say deploy a new web app. I fill in this information, check the box, click deploy, thinks about it, creates a web app, and then I can just say launch the web app. It's going to open up a web browser window. Again, by default, they make it so you have to sign into it, but again, you can make it so you don't have to do that if you don't want to. And then at this point, I can start chatting. So I put the question in. It then gets a response based upon what was, what information it has. In this case, there's two different parts of the PDF. If I click on it, you can actually see this is the raw PDF information, right there. So this is the method for, creating a LLM that talks to only your data. So the last part of this is I'm going to show you how to do this yourself using just SQL Server. And this is, way less expensive. Any questions at this point? Okay, so let's go ahead and dive in. So this is the app that we're going to create. So a person can load data.
We have just one question, just asking if everything that you are explaining here is covered in your book.
Everything is covered in my book. Every application I'm showing you here, you can download for free from my website. You just have to create an account. Don't worry, I don't spam you. I don't sell my list or anything. The only reason why I gather emails is because when I release a book, I do send out, an email saying, "Hey, I wrote a new book." But you can then download all this code. And everything I'm covering here is covered. There's a blog post on everything I'm covering. The reason why you want to get the book, however, is the book starts from the beginning, goes to the end, you know what I'm saying? Whereas my blog posts are all jumping around and, But yes, every single thing we're covering here is in the book. So this sample app that we're creating here, what it does is this screen is showing you the raw information that is sent to the LLM for the response. So yeah, first it starts off with you load the data. I then chunk the data into chunks and I create the vectors. And then when a person types in a prompt, they get a response back based upon the data that was ingested. I even have the references. And again, I show this is the raw data that the AI had to use. So the first part is data. They click load data. It opens up a window. They give it a title. They put in as much content as you want. You click submit. When you click that button, whatever you put is chunked into 200-word chunks. Embeddings are created, and it's all stored in a SQL database. So here it's showing you there's 27 chunks for what I just imported there. This is the database structure. So the person is putting an article, and the article has a name. Remember, I then chunked the article into 200-word chunks. So each chunk, associated with the article ID, there's an article sequence because I want to keep the chunks in sequence. And then you have the article content. So this is truly just the text content. For each of the content, you have embeddings, which are the vectors, which are associated with it. And what happens is that the embeddings are a series of 1,580 different numbers for each article content. And again, I'll show you later exactly what those look like. But these are the vectors, and this is considered an embedding. And this is what they look like. So for each article, so for an article detail, there's actually, this goes down to 1,500 of these. And for each one, it starts off with position 0 and goes all the way down to, 1,580. This is the value. This is what it looks like. So to humans, this looks like nothing, but to the computer, it means something. And if you took the vectors and you compare them to these vectors, the response you get back, it'll match and it'll be related. So for example, audio and MP3 are related. So this is what they look like. So if we click on the home button, the person is able to basically put in a prompt, click search, and then they'll get an answer. So if I said, where do I put my OpenAI key? It basically says, well, you can put your, you can put your OpenAI key in the API key field. And basically what happened was I actually imported a bunch of my own blog posts so that when you ask this question, it's basically searching my blog post to give you the answer. This screen here, search results, this is showing when I did the vector search, these are the results. And this right here represents the match to what the person put up here. This saying that this right here, this chunk of information was an 83% match to what's up here. This chunk of information was, 84% match, and so on and so forth. So it takes the top 10 matches and it sends all this information to the AI. So the question plus this information is sent to the AI, and this right here is the response that the AI gave. Make sense? Any questions? Okay, so now I'm just going to show you how this is built. So again, same thing, user enters prompt, search and perform, grounding is passed to AI, you get the answer. So to set this up, we need to deploy a model to create the embeddings. So we go back into the studio, we go to deployments, and we deploy a model. In this case, the model is called Text Embedding ADA 002. The nice thing about this is it's very, very inexpensive to operate. I mean, I use this thing pretty much every day, pretty much every day, 7 days a week. I'm embedding, just tons and tons of information. And when I get the bill back, it comes out to like 2 cents. So it's very cheap. So we deploy the model, and now we're ready to create our application. So again, this is the application we're creating, which is it's going to allow us to chat, but we're going to be chatting against, basically, in my case, my blog post. So we're going to start off with the app that we covered before. We start with that application, and we're going to add some stuff to it. So first, we're going to add some NuGet packages, SQL Server, obviously, so we can communicate with SQL Server. And for the UI, I like to use Radzin. It's a free, UI framework. We're also going to use EF Core Power Tools because we need to make a data layer. And of course, we're using just normal SQL Server Developer Edition. These are the tables. I kind of showed you the tables before. The only thing that's different is we have this function. And what this function does is this is how we do our vector searching, is this function. Now we'll show you the contents of that function. The reason why we can use SQL Server for storing our vectors, and we don't have to use some expensive vector database, is we're creating a column store index. And this index is how we get good performance when doing vector searches. So we're first going to create our data context. We right click, we say, because I install EF Core Power Tools, we say, we select it and say reverse engineer. We just click add, okay, select all our tables. We click okay, we click okay again, and boom, that's how it creates my data context. So I don't know whatever you guys are using for your data context, but this is what I use and it works great. We go into our app settings. We put in basically a connection to our SQL database. We go into programs, .cs. We, of course, that's our connection between the database settings and our app settings and the data context that we just created, and all that's set up. So the first thing we want to do is start creating the service. So I create a bunch of DTO classes. One here is to store the article, and this right here is to store the results that come back. So remember, for every article, I indicate, what the match was. This right here is for my embeddings, and notice that I was storing the values as floats, and that is actually a single vector, which is stored as a double. And so now I have my service. This right here just, is my data context. So we're communicating with the database. And then some methods to, get articles, get an article by ID, adding an article. This one is interesting. When I'm adding an article detail, what happens is that I pass the embeddings as a single string. I then break them up into floats, and then I loop through them all, and then I insert them into that table you saw on the right hand side, one at a time, and that right there is the actual value there. And then of course deleting articles. Now, when I get a prompt, okay, so I get a prompt, I need to first turn that prompt into embeddings. So say E. Then I then pass that into this method here, which will then search all the data that I have in the database to then give me a list of articles that match. So this is where I do the vector searching. So this guy here is this store procedure, this function here. And it's not that complicated. So again, this is it right here. And we're passing in the vectors, but it's a single string at this point. So what happens is that it comes into here, and we use this thing called OpenJSON with a CTE. So even though this is, a single string, it breaks it up into, a collection with the vector value ID, which again is from 1 to 1580. And this right here is the actual float value. So this right here is CTE vector. Now to search the database, so remember, this is my database. So actually, CTE vector is coming here, and it's V1. And these are my articles in the database here. So to do the search, it uses a function called cosine similarity, and this is basically it. So it's doing this thing where it takes the square root sum of the vector value and its position times the square root of this to come up with a cosine distance, and the cosine distance is how we say this is similar to that. So, and then basically I return the articles that match, and in this case I just say give me the top 10 that match. So this is where all the magic happens for the vector search. So back on my data page, this is that dialog that people open up to put in the information, the article content, and then when they click the close button, it closes. And this right here is where I am displaying all the articles that have been inserted into the database. So we haven't done any searching yet. This is just saying I added a bunch of articles to the database. And again, this is where I get my settings. This right here is just, like I said, just saying, show me the articles. However, this right here, oh yeah. However, when a person is adding an article to the database, this is what basically happens, which is I open up a dialog, and they put the information in, but then what they put in is result. I then take result and I split it into chunks of 200 each, and then I add the article to the database. But now I need to get the embeddings so I can store that in the database. So I open up the OpenAI client, and this right here is continuing the code here. But then I call get embeddings, and this is that model that I deployed, and I get the embeddings here, and that is what I then pass to that add article, and that puts the embeddings in the database. So that's how we get the data in the database. This right here is just a method that shows how I split it up into 200 word chunks. And I also call this normalized text because I want to get rid of certain, spaces and periods and that sort of thing. So this is called by this guy up here. And of course, we have a method for if I want to delete an article. So now this is the main page. So this course just setting up the page. This right here is that CSS for the chat bubbles. This right here is just displaying the chat bubbles, that you saw before. This, of course, is that button to call ChatGPT. And this one here is, there was a tab that showed the search results. So that's all this does is just show those when the vector search is performed. That's just showing that. Okay, so this is the code. This right here should look similar to the code from earlier. It's actually the same. I'll initialize. This code is the same. The scroll to the bottom is the same you saw before. The restart button is the same you saw before. Okay, so what's different? So this part's different. When a person types in the prompt, so up here on the screen, they typed in a prompt. So before, I just took that prompt, I passed it to OpenAI, I got a response back, and it displayed it. In this case, I take the prompt, I do the embedding, okay, just like you saw the same before, but I take whatever the person typed in, and I get embeddings. I then, and of course, then I can, like I said, convert it to a bunch of floats, but then I pass it to that store procedure. And then I get back the articles that are similar. And you say, do I now send that back to the user? No, I take those articles and I pass that to this right here is just me getting the top articles and sorting them. But what I want to do with this information is I want to pass this information to the AI, and then I want to get a response back to the user. So the way I do that is I concatenate all this information, the articles, into this thing called existing knowledge. Now I call the AI and I pass it an instruction where I pass this existing knowledge, which is, like I said, just, these are the articles that match the query. I pass it to the AI. So the magic is under get instruction. Get instruction, I'm going to jump to it, is this guy here. So I passed in that knowledge there. And I basically say to it, I say, answer the questions using the given knowledge only. So this is important, meaning I don't want the AI to go on any other data it was trained on. I only want it to base its answer on what I gave it. I basically say for tabular information, return as HTML table. I say always return in markdown format. So it's nicely formatted. And then I tell it, I go, each knowledge has an article with the actual information. I go, do not return that information, only return an answer. Always include the source name for each knowledge that you have answer, and that's so it can show the the reference, and sometimes you have to keep telling it what you don't want. So don't cite the knowledge that you don't, that's not don't cite knowledge that's not available in the knowledge list. I know that this right here is the same thing as this right here, but sometimes you have to like tell it twice. And I go, if you don't know the answer, say you don't know. So now remember, I told you the other thing was give it examples. So I give it examples. I have example 1 and example 2. So I basically say, if the question was, what is Microsoft Blazor? And I gave you this knowledge, your answer should be this and include the references. If the question is this, but I don't give you any knowledge, you should say, I don't know. And then I basically say, and this is the knowledge you have. And this is how it works. And then you get the response. So we'll just take a look at what that looks like. So again, to load the data, you can just click the load data button, give your article a title. In this case, it's one of my blog posts. I just posted the contents of my blog post, including the code. I click submit. It then chunks it into 200-word chunks. In this case, it made 56 chunks. And now it's in the database, ready to go. So now if we go back to the home page there, if we type, something in there, it's going to search all the stuff that I've loaded into the database, and it's going to come out with an answer. And that answer, and it indicates where it got the answer. If I click on search results, this is showing what was the result of the vector search, and this is the knowledge that was passed to the AI. And like I said, the quality of these answers is extraordinarily good. And so you just really gotta. So I would say, download the demo code and play with it, and I think you'll be surprised on how good it is. So again, everything I covered is in my book. It's available on Amazon.com, both as Kindle and as print. And basically, thank you.
Hey, no, thank you, Michael. Let me ask you myself a couple of questions, because to be completely honest, the theory for the vector part is a little like hard to understand,
hard to follow.
to swallow. Yeah.
Hard to follow.
But the implementation is really nice. The implementation, you can follow the code and you can say, okay, I don't know exactly all the magic going behind, but I know that if I take this data, I convert it as an embedding, I have my model over there, I can reuse it, I can save it. Let me ask you something. Why do we have to use the store procedure? Why can't we just not do that part in code?
You can. So for example, that program that I was showing you, that's a Maui program, because I didn't want people to have to download a SQL Server, to use this app. I'm actually using text files. So there, I literally store. As a matter of fact, let me just see if I could just quickly show what that looks like. Hold on 1 second, because I want to show you, because it does answer your question as far as I kind of want to show. Give me a second here. Minimize, zoom. It's almost there. 1 second here. Let me just share my screen for 1 more second here, just so I could show you. Okay, so that AI Story Builders thing, this is the raw files, okay? So, for example, that 3 Little Pigs thing, right? Remember I showed you I had these chapters, right? I open up a paragraph. What do I see here? What happens is that the vectors are stored I'm storing them as text. So when I do a vector search, I literally, load up the text file, I read this stuff here, and I do the cosine similarity search in memory. There's no SQL Server involved, or no database involved. And the performance is actually really good. The reason why, but the point is that when I'm doing searches, I'm doing it very limited. I'm saying I'm only searching so many files at a time. Whereas if you had, thousands of pages of documents, then you'd want to use a SQL Server. And then in order to do this, the similarity search, because it has to be done inside SQL Server, you would have to, use a function or store procedure. But this project here, does not use SQL Server. And this project here, you can download the code. It's not done yet. The thing will be fully done by December, but it's totally GitHub, it's totally open source. And so hopefully that answers the question that no, you do not have.
It does. But for example, I completely get the part about the speed part. A lot of time when we don't want to overload the application with data related issues, we move that logic to the store procedure, to database view, to something on the SQL side.
Right.
But for example, if you're there reading files, in theory, I can do the same thing. I can bring the data with a DB context, get the data in memory, do the search from there without having to do the store procedure, and still be using SQL Server. Is that correct?
Right. The only, like I said, the only problem you have is, limitation you have is that in some cases people are like, we have thousands of PDFs and we want to search amongst those thousands of PDFs. You would have to load all those PDFs into memory, do the search there. That would be slower than if you, and that's why the vector database vendors make a lot of money, is because they allow you to store terabytes worth of information into their vector databases. And when you do the search, it can search, terabytes worth of information in milliseconds. That's what you're paying for. SQL Server, you can store terabytes worth of information. You can do a vector search. However, it won't be milliseconds. It would be seconds if you had terabytes worth of stuff. If you have less than terabytes worth of stuff, which is what I have, it is milliseconds. So whereas this thing I'm doing here, that it only works for small amounts of information. It degrades, the performance degrades considerably if you have a lot of information.
Nice. Yeah, no, I was going to say that I think that comes hand in hand with the Elasticsearch talk that we had last part about the search part only.
Right.
But that definitely is a really interesting because that's the especially for all these line of business applications, that's the end result, to bring your own data and feed to your. So I cannot say how excited I am. I really appreciate the talk, Michael. That was amazing. Thank you for everything. As always, guys, everything that he covered is on the book. So I already got it. It's really comprehensive, more than 1,000 pages. So I'm going through it. I still haven't finished it. And we are now in an AI world. I was reading a tweet about the conference of the OpenAI that ended up 2 days ago. Yeah. And they are, I don't even understand it completely, but they are actually allowing you to do your own GPT, your own. So it's crazy the amount of things that is coming. So in that same regard, I want to say thanks again one more time to Michael. And for next month, for the first time in like almost 2 years, we will have an in-person event. So I'm really excited to come back so everyone can join. And we're going to be talking about AI as well. So Phil Hack will be flying here to Arizona. So he reached out and he will be able to get with us. And he will be talking about the practical application of generative AI. So I think that comes hand in hand with the topic of today. I definitely will download Michael's repo and I will go and start to play with it a little bit more so I can more prepare for the next talks. Michael, you are invited, of course, and thank you for coming. Hope to have you soon again here. And hope to see you soon at any of other conference, Ignite or MVP Summits next year. And
definitely be there.
I appreciate it. Okay, guys, see you guys next month as always, and talk to you soon.
Thank you.